Alcohols. IUPAC name of the alcohol is alkanols. General formula of alcohol is CnH2n plus 1 OH. Monohydric alcohols. Type of alcohol is there are three types of alcohols: monohydric alcohols, dihydric alcohols, trihydric alcohols. Monohydric alcohols means if hydrocarbon contains one OH group, we call it as monohydric alcohols. And dihydric alcohols, if hydrocarbon contains two OH group, we call it as dihydric alcohols. Example, ethane 1,2 diol. General name of this compound is ethylene glycol. Trihydric alcohols. If hydrocarbon contains three OH group, we call it as trihydric alcohols. General name of this hydrocarbon is glycol. And sorbitol is the example of polyhydric alcohols. Vinyl alcohols are involving in tautomerism to convert into carbonyl compounds, that is aldehyde and ketones. Phenol. Phenol means if benzene ring contains OH means we call it as phenols. That means if one hydrogen is replaced by a OH group means we call it as phenol. Cresol means if alcohol is contains one CH3 group means we call it as a cresol. If it is present in ortho position we call it as orthocresol. If it is present in meta position we call it as metacresol. If it is present in para position we call it as paracresol. Preparation of alcohols from haloalkanes. In first, from alkyl halides. That means when alkyl halides are treated with the strong alkalis, means strong bases like NaOH, KOH or moist silver oxide, it gives alcohols. Example, alkyl halides are treated with the NaOH, KOH, Ag2O, means silver oxide, it gives ROH, NaX. It follows a SN2 mechanism, and order of elimination reaction is tertiary is greater than, secondary is greater than, primary is greater than alkyl halide. Next, from alkenes. When alkenes are treated with the water, it gives alcohols. Example, alkenes are treated, ethene is treated with the water, it gives ethanol. Means it follows Markovnikov rule. Markovnikov rule means negative part of the hydrocarbon is attached to double bonded carbon which contain less number of hydrogen. That is called as a Markovnikov rule. It is an example of alkenes. When treated with the water, it gives alcohols. And next one is by hydroboration, oxidation of alkenes. When alkenes are treated with the diborane in the presence of tetrahydrofuran and H2O2 in the presence of OH minus, it is involving in hydration to give alcohols. It follows anti-Markovnikov rule. That means it is an alkene when it is treated with the B2H6 or tetrahydrofuran in the presence of H2O2 and alkali, it gives alkanol. It follows anti-Markovnikov rule, means negative part of the hydrocarbon is attached to double bonded carbon which contain more number of hydrogen, and THF is prevents the dimerization of BH3. Next one is oxymercuration and demercuration of alkenes. When alkenes are treated with the ACOH OAC, means mercuric acetate, in the presence of water, it gives alkanols, and it follows Markovnikov rule. Next one is preparation of alcohol from carbonyl compounds by Grignard reagent. Alkyl magnesium halide is called as a Grignard reagent. When carbonyl compounds are treated with the Grignard reagent to form intermediate, when it is subjected to hydrolysis, it produces primary, secondary, tertiary alcohols. For example, this is ketone. Ketone is treated with the Grignard reagent. In the presence of ether, it gives an intermediate. It is the positive part of the carbon attached to the negative part of the alkyl group. Then it is converted into a intermediate. And when it is subjected to hydrolysis, it gives alcohols. Means H plus and OH minus. Negative part of the oxygen is combined with the positive part of the water, that means H, and positive part of the Mg is attached to the OH minus and forms as a secondary alcohols and MgOX and X. Ketone always gives tertiary alcohol when it is subjected to the Grignard reagent and treated with the Grignard reagent and subjected to the hydrolysis. It always gives tertiary alcohol. And preparation of alcohol by reacting of acid derivatives with Grignard reagent. When ester combining with 2 moles of Grignard reagent to form tertiary alcohols, this reaction as follows. Negative part of the this compound is attached to the positive part of the Grignard reagent and forms an intermediate, and is subjected to the hydrolysis. It gives a ketone, and when it is again treated with the Grignard reagent, it gives an intermediate, and again it is subjected to hydrolysis. It gives tertiary alcohols. It means this oxygen is combined with the Mg and its carbon is combined with the R. Then it forms as a RCOR, RCOMgX, and this compound will be formed. When it is treated with the water, then this compound will form. Finally, it gives tertiary alcohols. This is called as a tertiary alcohols. When methyl ester is treated with the 2 moles of Grignard reagent, it gives secondary alcohols. And formyl halide is treated with the 2 moles of Grignard reagent, it gives secondary alcohols. And when acetyl halide, ethanoyl halide is treated with the 2 moles of Grignard reagent, it also gives tertiary alcohols. And this mechanism is here. Preparation of alcohol from carbonyl compounds by reduction. When the compound is treated with the 2 hydrogen in the presence of hydrogen, platinum, palladium, nickel at 200 degrees Celsius temperature, lithium aluminum hydride or sodium borohydride, it reduces as a aldehyde or ketone. Aldehyde or ketone to alcohols. But in this reaction, tertiary alcohols are not at all formed. And in this compound, what is this name of the compound? Aldehyde. Aldehyde is treated with the hydrogen. One hydrogen is combined with this carbon and one hydrogen is combined with this oxygen and formed as a alcohols. And it always gives alkynols only. Lithium aluminum hydride and sodium borohydride do not reduce double bond and triple bond, but it reduces aldehyde and ketones into alcohols. But hydrogen or platinum reduces both double bond and triple bond along with the carbonyl compounds. In exception cases, double bond present on alpha carbon attached to benzene ring is reduced by lithium aluminum hydride or sodium borohydride. Preparation of alcohol from acid and its derivatives. When aldehyde are treated with the 4H plus in the presence of lithium aluminum hydride, it gives alcohols. 2 hydrogens are combined with this one and 1 hydrogens are combined with this one and 1 hydrogen is combined with this one and removed as a water, and we got alcohol as a product. Sodium borohydride does not reduce acid and ester, but it reduces acyl halide. Lithium aluminum hydride reduces all. It means it reduces acid, ester and acyl halide also. And preparation of alcohol from ethers. When ethers are treated with the water in the presence of dilute H2SO4, it gives alcohols. Means this H plus is combined with the negative part of this compound that is O minus, and this OH minus is combined with these components and formed a product 2 moles of ROH. Example CH3OCH3. This combined with the water in the presence of dilute H2SO4, it gives 2 moles of methanol. Means 1 H plus is attached to this oxygen and OH minus is attached to this compound and form 2 moles of methanol. And in this reaction, another example is when this compound is treated with the water in the presence of dilute H2SO4, H plus is attached to this oxygen and form as a product methanol, and this OH minus is attached to this compound and formed as a ethanol. In acid, the hydrolysis oxygen retains with a carbon which possesses less number of carbon. It follows SN1 or SN2 mechanism. If primary and secondary alcohol is there, means it involves SN2 mechanism. Tertiary alcohols involves in SN1 mechanism. And when esters are treated with the water, it gives acid and alcohols. When esters are treated with the water, means negative part of this ester O minus is combined with the H plus and formed a product acid, and this R is combined with the OH minus and formed as a alcohols. And ester general name is alkyl alkanoate. From amines, when primary amine is treated with the HNO2, that means it's a mixture of sodium nitrate and HCl at 0 to 5 degrees Celsius, it gives alcohols. That means when primary amine is treated with the sodium nitrate and HCl at 0 to 5 degrees Celsius, it gives alcohols. RNH2 means primary amine is treated with the NaNO2 and HCl. It forms the HNO2. When it's treated with the primary amine, means it forms a product as alcohols and N2 and H2O. And preparation of alcohols by fermentation. Molasses is a black viscous in nature. When sucrose is treated with the water in the presence of invertase enzyme, this invertase enzyme is converted sucrose into glucose and fructose. And this glucose is converts the Zymase enzyme into ethanol and carbon dioxide is formed, means evolved. Preparation of methanol. When water gas is treated with the zinc oxide and chromium oxide in the presence of 600 degree Kelvin temperature and 200 atmosphere pressure, it gives methanol. Water gas means it is the mixture of carbon monoxide and hydrogen. Is enriched with the hydrogen in the presence of chromium oxide and zinc oxide at high temperature and high pressure. It gives methanol. And when methane is treated with the oxygen in the presence of or it passed through the red hot copper at high pressure, it gives methanol. Chemical properties of alcohols. Cleavage of ROH bond means the bond is break between O and H. Then it is explains the acidic nature of alcohol. When alcohols, when the bond is break between RO and H, it explains the acidic nature of alcohols. Means this electron pair is gained by this oxygen and H is removed as a H plus, and in this reaction alkoxide is formed. And we should use in this reaction as a high electropositive metal also. Acidic nature of alcohols. Strength of the conjugate bases increases, acidic nature will be increases. Conjugate base. The order of conjugate base is CH3O minus is greater than CH3 twice CHO minus is greater than CH3 thrice CO minus. As negative charge increases on oxygen, stability will be decreases. Acidic nature is inversely proportional to the plus I group. As electron withdrawing group is increases, acidic nature will be decreases. Primary alcohol is greater than secondary alcohol is greater than tertiary alcohols. Electron withdrawing group is means NO2. These are the examples of electron withdrawing group. And acidic nature is phenol is greater than methanol is greater than water is greater than alcohol is greater than alkyne. And reaction with sodium, when alcohol is treated with the metal, it gives uh, metal oxide, and NH3 and hydrogen is evaporate. When the 2 moles of methanol is treated with the sodium metal, it gives sodium methoxide and hydrogen is formed. And reaction with alkali like NaOH, KOH, NaOH plus KOH, ROH plus NaOH does not give RONA because do not have sufficient acidic nature to combine with strong alkalis. And reaction with metalamide, when alcohols are treated with the metalamide, they produce metal alkoxide and liberate ammonium gas. Negative part of this alcohols O minus is combined with the positive part of the metalamide M plus and removed as a metal oxide, and NH2 is combined with the H plus and removed as a NH3. Esterification reaction, when acid is treated with the alcohols, means alcohols reacts with the carboxylic acid in the presence of acid like mineral acid or HCl to give esters. This phenomenon is known as esterification. If HCl is used as a reagent catalyst, this reaction is called as a Fischer esterification. This acids act as an electrophile while alcohols act as a nucleophile and is combined with each other and forms a ester. This reaction is known as esterification reaction. This negative part of the acid oxygen is combined with the positive part of the R and formed ester and removed as a H2O. This OH is combined with the H and removed as a H2O. It is nucleophilic substitute reaction. Stability of carbocation is tertiary is greater than secondary is greater than primary is greater than carbocation. With acid derivatives, when acid halide are treated with the alcohols in the presence of pyridine, it gives ester. Means when acyl halide or acidic anhydride are treated with the alcohols to form esters in the presence of pyridine, this reaction involves in acylation, means addition of acyl group. Then it forms ester. Acyl halide treated with the alcohols in the presence of pyridine, it gives ester. And acid anhydride, it is treated with the alcohols in the presence of pyridine, it gives acid and ester. And aspirin means acetyl salicylic acid is called as aspirin. When salicylic acid is treated with the acetic anhydride, it gives acetyl salicylic acid. It is also called as aspirin. Salicylic acid means we call it as this compound as a salicylic acid and is treated with the acid anhydrase. It gives us a product acetyl salicylic acid. We call it as a aspirin. This aspirin is used as an antipyretic and anti-analgesic. When alcohol is treated with the Grignard reagent, it gives main product as a alkanes. In this reaction, the bond break between O and hydrogen. These are involving in the nucleophilic substitute reaction. Reaction with halide, when ROH means alcohols are treated with the hydrogen halides, it gives alkyl halide. Means in this reaction the bond is break between R and oxygen, and the R is combined with the X and formed as a alkyl halide. Rate of hydrogen halide is HI is greater than HBr is greater than HCl. Rate of alcohol is tertiary is greater than secondary is greater than primary. Reaction with HCl. When alcohols are treated with the HCl and zinc chloride, it gives RCl, means alkyl halide, and it removed as a water. HCl and zinc chloride is combinedly called as a Lucas reagent. This reaction is used to distinguish between primary, secondary, and tertiary alcohols. Lucas reagent means it is the mixture of concentrated HCl and anhydrous zinc chloride. If primary alcohols is there, then no PPT, means by warming only it gives PPT, white PPT. Secondary alcohols react means it gives after 5 minutes it will give precipitate. Tertiary alcohols react means it will use immediate turbidity or immediate white PPT. Reaction with phosphorus trichloride and phosphorus pentachloride. When alcohols are combining with a phosphorus trichloride and phosphorus pentachloride, they produce haloalkanes. This means when 3 moles of alcohol is treated with the PCl3, it gives 3 moles of alkyl halide and H3PO3. It is a acid. And when alcohol is treated with the phosphorus pentachloride, it also gives haloalkane and POCl3 and HCl. This Cl is combined with this R and this PaCl3 is combined with this O and this Cl is combined with this H and removed as RCl, POCl3 and HCl. And it is involving in the SN2 mechanism. It gives inversion product. It involves in a SN2 mechanism. And reaction with the SOCl2 means thionyl chloride. It is also called as a Darjan's process. When alcohols are treated with the SOCl2 means R is combined with Cl, O is combined with SO, H is combined with Cl. In the presence of pyridine, it gives haloalkanes and SO2 and HCl. It is the best method to prepare haloalkanes. It follows SN2 mechanism, means reaction with thionyl chloride follows SN2 mechanism. Dehydration of alcohols, or it is also called as elimination reaction. When alcohols are treated with the strong dehydrating reagents like concentrated H2SO4, sulfuric acid, or potassium hydrogen sulfate, or H3PO3, it gives alkene, means it is involving in the elimination reaction. This H is combined with this OH and removed as a water, and this bond is goes this side and formed a alkene. This reaction is involved in even mechanism. And oxidation of alcohols. When primary alcohols oxidize, it gives aldehyde, and secondary alcohols oxidized, it gives ketone. But tertiary alcohols do not produce any derivatives, but it gives alkenes. And types of alcohols. It is a primary alcohol combining with or reacting with a KMNO4. It formed an aldehyde. When it is treated with the further oxidation, it gives acid. But when secondary alcohol is treated with the H plus KMNO4, it gives ketones. Already ketone is stable, it does not involve further oxidation. But in the presence of HNO3 and high temperature, it involves in oxidation. Generally, tertiary alcohols are do not involving in the oxidation, but in the presence of acidified KMNO4 or K2Cr2O7, it is involving in the oxidation. It's potassium permanganate and potassium dichromate, it is involving in the oxidation. Next one is dehydrogenation of alcohols. When primary alcohols are treated with the copper at 300 degrees Celsius, it gives aldehyde. This reaction is used for the distinguish between primary, secondary, and tertiary alcohols. When alcohols are passed through the hot copper at 300 degrees Celsius, it gives primary and secondary alcohols involving in dehydrogenation to give aldehyde and ketone. Tertiary alcohols are involving in dehydrogenation to give alkanes. It is primary alcohol passed through the copper at 300 degrees Celsius. It gives as a product as a aldehyde. And when secondary alcohols are treated with the copper at 300 degrees Celsius, it gives ketone. And when tertiary alcohols are passed to the copper at 300 degrees Celsius, it gives alkenes. Mild oxidizing agent. It is a PCC, means pyridium chlorochromate, Jones reagent, chromic acid in acetone, Collins reagent, pyridine and chromic oxide and CH2Cl2, Sarret reagent. It is all. These all are called as a mild oxidizing agent, but these are not oxidized as double bonds, but it oxidizes only primary alcohol into aldehyde, secondary alcohol into ketone. But MnO2, it is oxidizes benzylic and allylic alcohols only. That means uh, that means primary benzylic and allylic alcohol are converted into aldehydes. Secondary benzylic or allylic alcohol are converted into ketones. And haloform reaction. When alcohols are treated with the halogen in the presence of strong alkalis, it gives haloform. This is the main reaction. Ethanol is treated with the 3 moles of halogen in the presence of 6 moles of alkali. It gives CHX3 and 5NX and HCOONA. Like that, when ethanol is treated with the 3 moles of chlorine, it forms chloroform. And reaction with chlorine. When alcohols are treated with the chlorine, it gives ethanol. And Victor Mayer test. When primary alcohols are passed to the red phosphorus and iodine, it gives alkyl iodide, and it passes to the AgNO2, it gives oxime of nitroalkane. And when it is further treated with the sodium hydroxide, it is soluble and it is in color of red. If red color is formed means it is the indication of it is primary alcohols, and secondary alcohols are there means it is insoluble and it is in blue color. If tertiary alcohols are there means there is no color. It is a distinguished test between primary, secondary and tertiary alcohols. And reaction with bleaching powder formula CaOCl2. When alcohols are treated with the CrOCl2 in the presence of high temperature, it gives ethanol and calcium chloride and water, and further it gives chloral if and further it gives chloroform. And ceric ammonium nitrate test. When alcohols are treated with the NH4 3C cerium NO3 taken 6 times, it gives red PPT. And at last, physical properties of alcohols are poisonous in nature except ethanol. And solubility. As number of carbon atom increases, solubility will be decreases. Order of solubility. As number of carbon is inversely proportional to the solubility. It means as number of carbons increases, solubility will be decreases. And branching is directly proportional to the solubility. And melting point is also directly proportional to the molecular weight. As melting point increases, molecular weight also increases. And boiling point. Alcohols have higher boiling points as number of carbon directly proportional to the boiling point. As number of carbon increases, boiling point also increases. But as branching increases, boiling point is decreases. And number of OH group is directly proportional to the boiling. and boiling point is increases due to their intermolecular hydrogen bonding. These all are the physical properties of alcohol, and we have three tests for distinguish between primary, secondary, tertiary alcohols. These are Lucas test, Victor Mayer test, dichromate test. In this test, we can identify whether it is primary alcohol or secondary alcohol or tertiary alcohol. And the order of solubility. Uh, Tertiary alcohol is greater than primary alcohol, means in this reaction, as branches increases, solubility will be increases, and as number of OH group increases, solubility will be increases. So this glycol is greater than this propane 1,2 diol. Boiling point order, as number of carbon increases, boiling point will be increases. So C6 is greater than C5 is greater than C4, and as branches increases, boiling point will be decreases, and number of OH group is increases, boiling point will be increases.